All right, so in chapter 5 of the textbook, we're going to be covering sampling and sampling procedures. So within social work research, there's a few different ways that we can go about collecting sample data. Depending on the research question that we have and the type of population that we want to work with, there's more and more implications and considerations for coming up with a sample that we might be interested in reaching. Pie in the sky, it would be nice to reach a full population, but given the limited resources that we have, we often have to pick a smaller sample. So as far as terms that you should be aware of, a population is an entire set of individuals or other entities. You can think of a population as the population of the United States or the population of Milwaukee. It would be the entire set of individuals that make up that group. So a sample is a subset of that population of interest. So you could think of maybe instead of the entire student body of University of Wisconsin-Milwaukee, maybe a sample might be individuals enrolled in 662 online. And an element is an individual member or other entity of the sample. So that could be like an individual person that's within that sample. So each single participant would be an element of that sample. So a sampling frame is a list that contains all the elements of the population that are selected. You could think of something really basic like the US Census gives us a list of everybody that's a US citizen, and that would be like our large sampling frame that we would select populations from or samples from. Whereas an enumeration unit is a unit that contains one or more elements from the sampling frame. So you could think of it as like a household from the census that has multiple samples or multiple participants within that household. And sampling units are listed at each stage of a multiple sampling design. So again, a sampling unit, like if you were looking at a neighborhood and there's 50 households in that neighborhood, a sampling unit would be one of the households within that neighborhood of 50 different houses. So one of the key terms from the textbook is generalizability. If we're conducting a study, we want to make sure that our results are generalizable across population. Sample generalizability can mean if we're trying to learn about the effectiveness of a program within an urban population, would it necessarily be generalized to a rural population? If we're conducting a school-based intervention in Milwaukee, would it be generalized to a school that might be in Cleveland? Or would it be necessarily generalizable to a school in Anchorage, which is significantly different than Milwaukee? Or would it be generalizable to a different country even? Would it be generalized to schools in Guatemala? It may or may not be. That's what we mean by generalizability. And cross-population generalizability, again, might be across different sets of people or different conditions, different geographic or different cultural components can go into cross-population generalizability. So ultimately, when we're evaluating generalizability, it depends on the sample quality. So that's why you see people putting a lot of effort into trying to find samples that are high quality and that address the questions that the researchers are getting at. And oftentimes we take a smaller sample and try to make statements about whether this could be transferred into a larger population. If we were to look at an intervention for decreasing child neglect, we might take a small population within a certain clinic and see if we can really generalize our findings or our intervention to a larger, broader population. Certainly it would be great if we had the resources to do a full population, but generally we don't have the time or the money to do that. So we take a small sample and then try something out there and see if we could potentially translate it into like a larger, fuller sample size or a broader population. So if we're to assess generalizability and assessing diversity, we want to try to find a representative sample or a sample that's representative enough of the population that we're serving. So one of the issues that we often see in social science research is that there's an overrepresentation of certain ethnic groups and maybe like an underrepresentation of others, which can cause issues when we're trying to generalize our findings. If we can look at the graph on the bottom left and the graph on the bottom right, it's pretty much identical, the sample demographics with the population demographics. So that's what, when we're coming up with the sample, we want it to be as representative as the broader population as possible, which can be quite challenging actually when we're coming up with recruiting and trying to figure out if our sample does really represent the population that we're trying to make our generalizations to. So I think it's an important thing to discuss the ethical practices of sampling too. Certainly we can think of examples historically of where people have taken advantage of at-risk populations. So The example here is in the 1950s. Perry Hudson was looking at the effectiveness of prostate screening in reducing cancer. So he sampled homeless alcoholic men in flop houses in Manhattan. But if they did screen positive, he didn't provide any kind of medical follow-up. And the men who did participate often had painful biopsies as well. This was clearly an ethical violation of a convenient sample population used in the name of science. So since this time, there's been new standards for protecting vulnerable populations. So you can imagine other examples where there might be captive populations where, for instance, like in a prison setting, you might wonder if somebody really does have informed consent, whether they can really decline participation, kind of based on their situation. They might almost be kind of forced to participate unless certain stipulations were set up through an institutional review board. And that's why studies these days all have to be voted and approved by a review board of professionals in the field who are often uninvolved in the study and really don't hold any stake. Okay, so I'm going to go through a review of all the different sampling methods: random sampling, probability sample, simple random sampling, systematic random sampling, stratified random sampling, and cluster sampling. That's a lot of different forms of sampling. For the purposes of the quiz, you're probably not going to need to know all of these, and I'll review these in the review section, the ones that you do need to remember for purposes of the quiz. But it's important to know, like when you're reviewing articles, what the different terms of sampling means and how they came up with the population that they did, and that can help you to understand the implications of the actual study. So random sampling is exactly like it sounds. Elements are selected only on the basis of pure chance and the probability of selection. But one of the issues here can be systematic bias in that elements other than chance are present in the selection process. So even though we think we might be doing something completely randomly, sometimes there's systematic biases in the way that people are selected. A study, for instance, might say that they randomly selected parents by chance to participate in a parenting program. But maybe it wasn't random. Maybe it was the parents who enrolled first to Child Protective Services, or parents who were not screened out for having a substance use disorder. So it wasn't really random. And it's kind of up to the reader to determine whether or not that's truly the case. So with probability sampling, how likely is it that any element or population will be selected from the sample? The idea here is that everybody in a population would have the same probability of being selected for the sample size. So it might be using like a computer to give you information on the probability of selecting a certain number of individuals. Or you might be, instead of drawing a name out of a hat, maybe there's random digit dialing or random forms sent to individuals' houses within the probability sample. So probability sampling, some of the rules are the larger the sample, the better. The more confidence we have in the sample's representativeness. Always the bigger sample size, the better in any kind of social research, because the more likely we are to have a representative sample, and the less likely we are to be oversampling or undersampling a certain demographic. Also, the more homogeneous the population, the more confidence we have in the representative of the sample of any size. So in the United States, it's a little bit more difficult because we have such a diverse population here. But if we're looking at a homogeneous group of individuals, let's say I tend to work a lot with veterans. So if I'm looking at a rural veteran population and I'm trying to do an intervention with them, that's a relatively homogeneous group, rural veterans. And then I would have more confidence in the representativeness of my sample if I was going to be working with that specific demographic. So with simple random sampling, some procedure generates numbers simply on the basis of chance. So it could be a random number table, random digit dialing. The key characteristic is the probability of selection is equal for each element. So some examples or image of simple random sampling could be the larger population and doing like a coin toss. Either real or virtual coin toss, and every single element has the exact same chance of being selected. And you can kind of see we take the larger population, and through simple random sampling, we have a sample that should be pretty representative of the larger population as a whole. But there are some variations of this. One variant might be taking the total number of cases in a population and dividing it by the number of cases for the sample. And this is more of like a systematic random sampling. Step 2 would be to take the number inside sampling interval that's randomly selected And step 3 is every nth case is selected, beginning with randomly selected value plus the sampling interval. So you can read more about this in the textbook, and you can find some other examples, but you can see that this is a little bit more of a complex multi-step approach to simple random sampling, a little bit more sophisticated than just the flip of a coin. So with stratified random sampling, it's similar to simple random sampling. However, elements are grouped based on known population strata chosen randomly within the group. You could break it down to proportionate stratified sampling or disproportionate stratified sampling. So we could say if there was a population where we wanted our sample to meet that population, then we would have similar percentages, versus if we wanted to have equal percentages of each group, we might have over-representativeness of certain individuals. So an example might be if we knew the demographics of the larger population, we could have a proportionate sample, which would be similar to the full population that we can see on top, or we could do a disproportionate sample like the bottom right, where you might want to have equal numbers of each population within your sample. And there's reasons why researchers might do this. If we wanted to really have a good idea of the generalizability across cultures or across demographics, we might want to do a disproportionate sample. Versus if we wanted something that was going to be representative of the population as a whole, we might want a proportionate sample, as on the bottom left. So with systematic random sampling, we might do something like taking the first element selected randomly from a list of sequential files, and then every nth element is selected. So the northwest corner house of all 50 neighborhoods that we're going to be sampling from. An example of cluster sampling is the elements are selected from 2+ states, and then random selection of naturally occurring clusters within a randomly selection of elements. So a cluster is a naturally occurring mixed aggregate of elements. Okay, so cluster sampling is a 2-stage procedure in which first the researcher randomly draws a random sample of clusters, and then next the researcher draws a random sample of elements within each of those selected clusters. Here's an example of the different stages that go along with cluster sampling. So stage 1 is to randomly select states, for instance, and then from those randomly selected states, you can see Georgia here, randomly selecting cities and towns and counties within those states. Stage 3 would be to randomly select dwellings within those cities and towns. Stage 4 is to randomly select individuals within each of those dwellings. So you can see the different stages that go along with this, starting from randomly selecting a larger group, a larger pool, and then kind of selecting random clusters from within those larger units. So when comparing the benefits and cons of probability sampling and choosing the best form of sampling, it kind of depends on the research goals and data being collected. So if you want a truly randomized group, then you might be more purposeful in making sure that all individuals or all units have the equal likelihood of being selected. Versus if there's a more specific type of question that you might ask, or a harder to reach population, you might choose a different sampling method. So some non-probability sampling methods are availability sampling, which is just the element is chosen out of convenience to the researcher. You often might see this in something like an undergraduate psych course or undergraduate social work course, where the elements are basically the most convenient sample to get. Quota sampling might be a set element-based quota to ensure the population representation. So you might want to have a specific number of each type of individual or each demographic which might meet a certain quota that you might want to be more represented within your sample. Purposive sampling, elements each chosen for a specific reason or for a specific purpose. So you might think of something where it might be more difficult to find like a savant or maybe somebody who's like a really targeted individual. You could even think of something like a specific type of substance user, for instance. You might not want to have everybody within a population have equal likelihood of being chosen. You might want a specific type of person to be able to be chosen. Also snowball sampling, where each element might lead to more elements, such as if somebody were to identify somebody who might meet a demographic that you're interested in learning about, they might be able to help you find out more people that also are within that demographic. So you could think about, I'm going to post an article online about a process of identifying males with HIV, for instance. Somebody might potentially lead to finding more people who are in that demographic. There are also some ethical kind of implications for confidentiality here, but this is one way that's been done to help reach more difficult to get to populations. So I guess that's up for debate as well, and certainly something that would be discussed in depth with an IRB committee. So some other implications for non-probability sampling, qualitative research and generalizability. In order to increase generalizability, the researcher must study the typical type of element we might want to be studying, not just out of convenience. We'll talk further about true experiment versus quasi-experiment. If you want to really have something that's generalizable, you would want to have somebody be truly randomly selected. You might also want to perform multi-site studies to confirm localized results. So for instance, in my dissertation, I chose one specific hospital, and one of the limitations of that is that I might not be able to say that my results are generalizable to a different hospital. So having multi-sites study, it really increases the generalizability of your findings in order to be able to say that your results might hold true across different populations and different settings. So within samples, there's always going to be some sampling error, and we can use inferential statistics to help us to kind of estimate that sampling error. Also properties of a sampling distribution. We can look at sample statistic. Again, there's more in your textbook about this, but I'll try to post some articles related to this. Likewise, probably beyond this course, but there's quite a bit that goes into determining a sample size. We can estimate sampling error, and the more homogeneous a sample is, the smaller the sample size we need. But if we're going to try to make something more generalizable to a larger population, then we would want a bigger sample size. And those all factor into determining what the size of the sample that we may need. So on to inferential statistics, which is an estimate of how likely it is that a statistical result based on data from a random sample is representative of a population, of a larger population in which it was selected. And again, you probably don't need to know the process of this, but just so you're familiar with what this means if you see it in a paper, sample statistic is a mean computed from sample data, or an average, identical to a population parameter, which signifies a high level of confidence in the representativeness of the peak of the bell curve value. So again, within this module, you'll learn more about the bell curve and kind of what would be expected within a normally distributed sample. And just a few final thoughts here on sampling. When determining sample size, the larger the sample size, the better. When you have smaller sample sizes, there is more likelihood of having sampling error, particularly like related to systematic bias in selecting a sample or selecting too many individuals from a certain subsect of a population. Likewise, when you have a more homogeneous population, you can have a smaller sample size. So for instance, if we're looking at an intervention for a specific type of student, if there's a pretty homogeneous group that we're looking for generalizations to be made towards, we can have a more homogeneous sample group within our study. But if we're going to be looking at a more diverse population, then we're going to need some more diversity within our sample, because otherwise we're more likely to make sampling errors and have less statistical power in making certain types of generalizations or using information from our study to make implications about a different population. So, and then the last point here, more analysis anticipated from research, the larger the sample must be. So if we're going to try to make some more lofty statements about an intervention working or a program's effectiveness, then we're going to need to have a larger sample size to make those kind of generalizations. Similarly, if we're going to have a stronger relationship between two variables, the more statistical strength that we have to make those generalizations. So if there's a really strong relationship or bivariate or multivariate relationship between the variable of interest between our independent and dependent variable, we can get away with a smaller sample size as well. And just a few more points here about sampling within a diverse population. It's important to build credibility by involving key community members. So if you're trying to get at a hard to reach population, I think I already gave the example of working with native or indigenous populations with research that I've done in the past. I first made relationships with people who were involved with the community, somebody who would be like a good representative of the population that we're hoping to serve through our research, and that way that we've got that credibility going in. Also use culturally adapted procedures, also measures. Certain types of measures don't necessarily translate across different languages, so making sure that you're using something that's already been normed or potentially has some kind of standardized measure that can be used for the population that you're hoping to work with. Another point here is just thinking about what benefit it gives to the community that you're doing research with. So if you're really thinking about what's the benefit of me doing this research, if you really can't explain that so easily to a participant, maybe you should reevaluate whether or not it's worth actually doing. And then lastly, recognizing and accounting for cultural barriers and differences. So again, coming in from an outsider, you might have to really look at what your worldview is and certain kinds of assumptions that you may already have about a specific population that you're hoping to work with, and really check those when thinking about the research that you're doing. And lastly, just implications for evidence-based practice. In order to be successful in practice, one must understand that statistics value of a study and execution of a study. So when you're looking at developing your own research or looking at somebody else's research, it's important to think about as an informed consumer of research, if the statistical value that the authors are making is actually sound, and likewise how they've gone about executing the study itself. And on the flip side, it's good to consult with other experts in the field to make sure that your research is actually peer-reviewed by specialists in the area, not only just researchers, but sometimes it's good to speak with clinicians too, to see if your methods, assumptions, values are actually based in science and evidence-based rather than just based on like a feeling or some presumptions that you may have about a specific type of social problem.